In the next section, we're going to talk about another property of a function that has to actually deal with the slope, okay? So functions like the ones in the other examples that we've done are all curvy is the word he uses, but they're all kind of curved functions. So they increase and decrease at different rates. But something that we're all familiar with is speed, okay? So if you think about this, if you're driving a total distance of 130 miles in 2 hours, you know that your average speed, if you're going 130 miles in 2 hours, 130 for 2, your average speed is 65 miles per hour, okay? That doesn't mean that you were traveling 65 miles an hour the entire time. You probably started at 0, and then you probably were traveling 75 miles an hour, and then you might have slowed down because you went through a little town, and then you might drive like I do and go like 90 miles an hour, and then you slow back down. But your average speed the entire time, so if we do an average speed, so your average like slope, the average speed right here, this is your average speed, it's your linear speed, okay? So the line would represent your average speed, and it's the speed that is your distance divided by the amount of time that it took you to get there, okay? So what they did was they essentially found the slope between these 2 points. So this was your starting time, so time 0, and this was your final time, so final time, okay? And it's a speed graph, so we're graphing how much speed you did over time, so your starting speed, your final speed, and all of that, okay? So if you look at this is the distance at 2, the distance at 0, 2 minus 0. So you covered 130 miles from distance 2 to distance 0, right? Or 0 to 2, I guess. And then you went for 2 hours, so that's 65 miles per hour. So all you're doing is finding the slope. So you're finding the slope between the 2 points. And that's called the average rate of change on an interval, okay? So anytime they want you to find the average rate of change, you're looking for slope, okay? So the slope between those things at that point. So it's the same formula that you're used to for slope that you've been doing since Algebra 1. So f of b minus f of a, or you might remember it like this, y2 minus y1 over x2 minus x1. We're just going to put them all in terms of the function values. So f of b represents y2, f of a represents y1, b is x2, and a is x1. So it's just the coordinate at b, the coordinate at a, where a is the coordinate on the left, and b is the coordinate that's furthest to the right. Okay, so it's the same exact thing. So if you take a look at their graph, they've just kind of given you a graphical representation. So A is the point you'll start at, B is the point you'll end at, and you'll see that the rate of change is actually curved here, but your average rate of change is represented by the slope. So this distance is B minus A, and this distance is f of b minus f of a, so it's rise over run. So you can just plug those numbers in to the slope formula and figure out your average rate of change, okay? So let's do that over here in example 4. So they want you to sketch the function without a calculator and find the average rate of change on the following intervals. Well, we actually don't need to sketch the function to do this because it's all going to be algebra, but let me sketch it anyway just so that you've got kind of a picture of what's going on. So this is a parabola that's been moved over 4 units to the right. So 1, 2, 3, 4. So it looks something, assuming that that hits the axis right there, something like that. So it's just a parabola that hits the axis like that, and away we go. Okay, so they want you to find the average rate of change. So this is the slope on these intervals. This is that set notation, so in, right? So x over the interval x in 2 through 4. So this is my A, this is my B, okay? So the first thing I'm going to do is find f of b and find f of a. Okay, well my function that I'm using is x minus 4 squared. So if I plug in, b is actually 4, right? And a is actually 2. So if I do f of 4, that just means plug 4 into the function. Well, if I plug in 4, I get 0. If I plug in 2, 2 minus 4 is negative 2. And if I square that, I get 4. Okay, so the average, and I'm going to put ROC, rate of change. I don't feel any need to write everything out, is f of b, so f of 4 minus f of 2 over 4 minus 2. Well, f of 4 is 0, f of 2 is 4, and 4 minus 2 is 2. So this is negative 4 over 2. So my average rate of change is negative 4 divided by 2, which is negative 2. Really simple to do. Same thing for B, but this time we're going to need f of 5 and f of 8. So this is my A, this is my B. So it's just different ways to write the exact same question. Average rate of change from A to B. So I need f of 8, which is f of B. I need f of 5, which is f of A. So if I plug in 8, 8 minus 4 is 4. 4 squared is 16. If I plug in 5, 5 minus 4 is 1. 1 squared is 1. So the average rate of change is f of 8, because it's always the bigger number first, minus f of 5 over 8 minus 5. F of 8 is 16. F of 5 is 1. 8 minus 5 is 3. So the average rate of change, 16 minus 1 is 15. 15 divided by 3 is 5. So the average rate of change is 5 for every unit, okay? All right, and then the last one, same thing. So we're going to do f of 9, and we're going to do f of negative 1. Again, A, B. So f of 9, if I plug in 9, 9 minus 4 is 5. 5 squared is 25. If I plug in negative 1 minus 4 is negative 5. Negative 5 squared is 25. So the average rate of change is f of 9 minus f of negative 1. And I'm only writing this over and over again just so that you can see what the formula is. F of 9 is 25. F of negative 1 is 25. And 9 minus negative 1 is 10. Well, 25 minus 25 is 0. So the average rate of change is 0. That makes sense. Let's look at example 5. Example 5 is going to be the same kind of thing, but it's a word problem. When a pre-cal textbook is dropped from the top of a tall tower, the distance it's fallen after t seconds is given by this function. So this is the distance. They want you to find the average speed over the following intervals. Okay, so this is distance over time. Well, these are times, this is the distance, so it's the slope formula. Average speed is the slope. Okay, it's the slope using the distance. So we would need the distance for this section. This is A, this is B. So we would need the distance at 5, the distance at 1. Okay, well, the distance at 5, if I plug 5 in, 5 squared is 25, and 25 times 16, I should have brought my calculator. 25 times 16 is 3, 5, 8, 2, 1, 2, 3, 3 is 400. Oh, I should have known that. Oh well, 400. If I plug in 1 squared is 1, so this is 16. Okay? So then if I plug these in where they're supposed to go, I would know that the average speed, okay, the average speed is d of 5 minus d of 1 over 5 minus 1. So d of 5 is 400, the distance at 1 is 16, and 5 minus 1 is 4. All right? Well, 400 minus 16 is what? 384 over 4. Let's see if that reduces. So 4 would go into 38 9 times with 2 left over, so 96. So the average speed is 96. And they said seconds, but they didn't give me any sort of height. So we're just going to leave it as 96 because they didn't give me any sort of, excuse me, there you go. They didn't give me any sort of unit for the height. So we'll leave it like that. Okay? And then for B, Well, B is all in terms of variables. So this is A and this is B. So let's do D of A. Well, we're supposed to do D of B first, right? So let's do D of B and then D of A, which in this case actually is A. So D of A plus H would be 16 times A plus H squared. And D of A would be 16A squared. Okay, so let's put this in. So the average speed should be D of A plus H minus D of A over A plus H minus A. Okay, well, D of A plus H, this thing needs to get FOILed out. So if I FOIL out A plus H, that's A squared plus 2AH plus H squared. So if I multiply all of that by 16, I get 16A squared plus 32AH plus 16H squared. And then this D of A is just 16A squared. And if I look at the bottom, if I have A plus H minus A, the A's cancel, that leaves me with H. Okay, 16A squared minus 16A squared is going to cancel. And then both of these have an H, so I can divide an H out of both. So this is 32A plus 16H. So the average speed is 32A plus 16H.